We are discussing the inverse kinematic derivation of manipulators. So in this session, we will be discussing on how to derive the inverse kinematics of SCARA robot. Right. So here you have the SCARA robot with 4 DOF, this RRPR, and you have assigned frames for each joint, and also you have just derived the DH table, right, for all the 4 frames. You have derived the DH parameters A, alpha, D, and theta. So I'll not go into details of this derivation because we have already discussed in our earlier sessions on how to derive the DH table, and from the DH table how to determine the transformation matrices has been already discussed. So the right up straight away, I will just uh, uh, display the transformation matrices, right? So for each row if, of the DS table, you will get each transformation matrix. So we have 4 rows there. So we have 4 transformation matrices. And from that, you can get the forward kinematic model or the overall transformation matrix of frame 4 related to frame 0. So here in this, please note C1 to 4, it denotes theta 1 plus theta 2 minus theta 4, and S1 to 4, it denotes theta 1 sine theta 1 plus theta 2 minus theta 4. Okay. Now, in inverse kinematic problem, this end effector position and orientation is known to you. So the right hand side, whatever it is given, it is the known matrix, and we have already the forward kinematic model. We have this transformation matrix. So just by equating the two matrices, you will be getting this, right? So now, in order to get, so our objective is to get the joint variables for the given end effector pose, right? So that is you need to get theta 1, theta 2, D3 and theta 4. So these are the 4 joint variables. So as it is SCARA, it is RR, PR. So here you have to get the 4 joint variables. Now just for that, just we'll be equating this, that is 3 comma 4 on both the sides. So you'll be getting uh, L12 plus D3 minus L4 is equal to R34. So while discussing the solutions to inverse kinematics, I have told that always you just start with the positional component, because when you just try to just equate the rotational components, the solution may be getting somewhat complex. So I always start with just equating the positional component. So here I have just started with equating the R34 component with L12 plus D3 minus L4, and you can get here from this equation you can get our D3 variable, that is D3 is equal to R34 plus L4 minus L12. And similarly, when you just compare the this element, that is L2 cos 12 plus L11 cos 1, you will be getting on the right hand side it is equal to R14, and similarly L2 sin 12 plus L11 sin 1 is equal to R24. Now, if you just square and add on both sides, so if you just square and add on both sides, what you will get? So, for the first equation, when you just square, what you will be getting? I'll write it here. L2. So squaring this, so this means this first you will do the squaring. So it is L2 squared cos theta 12 squared plus L11 squared cos theta 1 squared plus 2L2 L11 cos 12 cos 1. So this is on squaring the left hand side, let's say, of the equation 2. Now similarly, if you just square the equation 3 on the left hand side, you will be getting L2 squared sine 12 squared plus L11 squared sine 1 squared plus 2 L11 L2 sine 12 cos sine 1, right? So if you just add both the left sides, that is left hand side, if you just add both the equations, so what you get? So you will be getting simply L2 squared. So this cos squared cos 1 2 squared and sine 1 2 squared becomes 1. So it is L2 squared plus L11 squared plus. So in this you can take a 2 L11 L2 common. So you will be getting cos 1 2 cos 1 plus sine 1 2 sine 1. So this you can just take it as cos A minus B. So we will be getting as cos A minus B this. So this will be getting L2 square plus L11 square plus 2L1 1 L2 cos A minus B means you will be getting cos 2, right? And then you the same way you just square and add on the right hand side, you will be getting R14 square plus R24 square, right? So just performing squaring and adding of the equations 2 and 3, you will be getting finally L11 square plus L2 square plus 2 L1 L2 cos 2 is equal to R14 square plus R24 square. So now from this equation, you can just get cos theta 2 as you see in the equation 4, the only unknown is theta 2, right? All other values are known. So you can get cos theta 2. But you have to in order to get the solution for theta 2, you should ensure that the values of this expression, it will just change between minus 1 to plus 1. So if at all the constraints are not satisfied, then it will not be possible by the manipulator to reach that particular position. So you have this sine theta 2 is equal to plus or minus root of 1 minus theta c2 squared. So if you can also express, so in order to get accuracy, you can express it in terms of tan 2 function. So you will be getting theta 2 as a tan 2 sine theta 2 cos theta, right? Now we have known theta 2. So from the equations 2 and 3, which we just solved earlier, we can compute the only unknown would be now theta 1. So using that express relation, you can just get theta 1. So how? So L2 into C1 C2 minus S1 S2 plus L11 C1 equal to R14. So L2 S1 C2 plus C1 S2 plus L11 S1 equal to R24. Or this we can write it as L11 plus L2 C2 into C1 minus L2 S2 into S1 is equal to R14, right? So that is, we have written this as this, that is L11. We have taken rewritten the eighth equation as L11 plus L2 C2. We have taken C1 common minus L2 S2 into S1 is equal to R14. Okay. Now again the second thing you have just rewritten off to this form, that is L11 plus L2 C2 S1 plus L2 S2 C1. So we have the reason for just writing bringing it to this form is that you can just apply the trigonometry identity, and we can just the two equations we can just present it as L11 plus L2 C2 equal to R cos pi and L2 S2 as R sin pi, right? So this so in both the equations we have just brought it to this form, so that we can represent this term, that is L11 plus L2 C2 as R cos pi and L2 S2 as R sin pi, where R is nothing but the distance, that is root of L11 plus L2 C2 the whole square plus L2 S2 the whole square, and pi is A tan 2 of L2 S2 by R and L11 plus L2 C2 by R, right? So the equations 10 and 11, what we have rewritten, so both the equations can be reduced to this form. R cos theta 1 plus phi equal to R14 and R sin theta 1 plus phi is equal to R24. So this is according to the trigonometric identity. So once we have got these two equations, so from these two equations you can just get theta 1 and theta 1 of the form theta 1 is equal to A tan 2 into R24 by R. So here as you see here. So from this equation, r sine phi theta 1 plus phi is equal to r24, and r cos theta 1 plus theta phi is equal to r14. When you just divide it sine by cos, you'll be getting tan. So that is why you get a tan 2 here. So r24 by r, comma r14 by r. And but you get a minus pi here, as because here the angle is theta 1 plus pi. So you want one theta 1. So you'll be getting the equation for theta 1 like this, right? So pi is already known. So pi you get from this. In the expression, you see that theta 2 already we have found. So all the values of for getting pi is already known. Okay, so from that easily you can determine theta 1, right? So this is how we get theta 1. So now we have got theta 1. So from the from theta, so by equating C1 to 4 and S to 1 to 4 from the transformation matrices, you get R11 and R21. So now as you got theta 1 and theta 2 you have got, you can get from these expressions, you can get theta 4, right? So theta 1 plus theta 2 minus theta 4 is equal to a tan 2 of r21 comma r11. So from that you can get theta 4, that is equal to theta 2 plus theta 1 minus a tan 2 r21 comma r11. So right, so we have got all the joint variables, that is theta 1, theta 2, d3 and theta 4. The expression for all the joint variables for the given end effector force has been determined now.